Math 1700. This is a really cool video, and I know you're thinking, Darbo, you're such a geek. Uh, yeah, okay. I got nothing for you. I am. But what we're going to do in this video is we're going to look at a couple of things. First of all, I want to talk to you a little bit about systems of linear equations. And I'm not sure that I'll get into it in this video or not because I never know how long I'm gonna how long I'm gonna talk. But we'll ultimately look at solving systems of linear equations a new way using matrices, and it's really cool. I mean, it's cool because it's a new mathematical object, if you will. Uh, it's a new technique. It honestly, it makes things easier. It really does. It makes some of the stuff that you've done uh, in previous math courses easier. Now, if we just to give you an example of it's kind of hard to get started here because I'm trying to think where I want to head with this because I don't use notes and stuff. I just kind of shoot from the hip. Let's say probably somewhere in the past, you have seen, I don't know, something like a problem like this. Let me do something that will have a nice kind of neat answer. Okay, and there we go. That thing collapsed on me again. I don't know why that happens. And typically we look at these things and they have kind of a bracket kind of thing in front of them. And the goal here is to solve the system of equations. Now, what we run into here is you can see that we have two lines. We have two equations. We have 2x plus y equal 8 and x plus 3y equal 9. Systems of equations come in three forms. First of all, again, you can think of this as just being a line, and let's just call that L1. And then we might have another line that comes in like this. Let's call this L2. So the solution to a system of linear equations is just the point that the two lines cross. Now, sometimes you get into parallel lines. For example, I'll try my best to draw two lines that have the same slope. So in this situation, L1 and L2, there would be no solution because with parallel lines, obviously the lines don't cross, so there's no solution. This is a unique solution. And in the business world, in finite mathematics more specifically, these are the types of systems of equations that we're going to run into. And there's one, just to be very thorough, there's a third kind of form too. And that would be where you have L1 and then you have L2, pretend I drew that right on top of that, where L1 and L2 are the same line. And in this situation, you would have infinitely many solutions because every single point that you have is a point where the line actually crosses because it's the same line. So there are these other three. We're not going to worry about those as much in applications. We're going to focus on this one right here. Now, I just I'm kind of curious. This is something I do when I'm teaching in class. Is I just kind of throw it out to my students. How would you solve something like this? And I just want to run through some of the things that you probably have seen previously. First of all, you could use a method like this. So if we have 2x plus y equals 8 and x plus 3y equals 9, what we could do is we could use the elimination, well, actually the addition. And we could see that if we multiplied this second equation through by -2, what would happen is we would get a 2x and a -2x here, so we could eliminate temporarily the x term and focus on the y term. So if we were to implement something like this, we would get 2x plus y equals 8, and we would get -2x -6y equals -18. Now, as we've talked about a little bit before, I think we talked about this a little bit when I was teaching exponential functions. We can add all the stuff on the left-hand side and add all the stuff on the right-hand side because they're equal. So if I add all this stuff over here, I get 2x minus 2x, which gives me 0x, so that eliminates. And then I've got y minus 6y, which we should all know is -5y. And then over here I get 8 minus 18, which is -10. So I'm going to divide both sides by -5. And I see that y is equal to 2. Now I can choose one of the equations that I started out with. I'm just going to choose this one, the 2x plus y equals 8. But I know that y has to be +2. So I can make this 2x plus 2 equals 8. I think we all see that that's going to be 2x equals 6. Divide both sides by 2, and we see that x has to be equal to 3. So our solution, therefore, will always be an ordered pair in the form x comma y. So our solution in this problem would be 3 comma 2. Okay, now this is what we call the addition method. And it's fine. There's nothing wrong with the addition method. It takes a little bit more work. I just happened to come up with a really easy problem here. But, you get into fractions, and those things become a little more challenging to do with the addition method. Okay, so my goal here is to make it easier on you, believe it or not. Now, another way that I want to talk about here, just to point out and reinforce that the solution to these things truly is the point of intersection. What I could do is I could take this 2x plus y equals 8, and I could put this in y equals mx plus b form. Now this is a really cool form to get any linear equation in, because we know very quickly the slope is -2, and we know that the intercept is +8. Now I've got to work a little bit harder on the x plus 3y, because there's going to be an additional step, because the leading coefficient of y is not equal to 1. So what the first thing I would do here is I would have 3y equals -x plus 9, and then I've got to divide through each term by +3. So ultimately, guys, on the left side I get y. Now students sometimes flip out on this. What's this -x over? I like to keep things where we have a coefficient in front of the x, and we can just think about this as always just 1x. So I would think of this as -1/3 x plus, and of course 9 over 3 is just +3. So what I have is I have two equations. Y equals -2x plus 8, and y equals -1/3 x plus 3. Now if I can graph and find the point of intersection, then what do I have? Then I have the solution. I have the solution to this system of linear equations I started with back over here. Now, that turns out it's really easy to do since you've got that fancy schmancy calculator that I required you to purchase. So all I have to do is go into y equal, and I want to get rid of the previous problem because it's no longer relevant. So if I go negative 2x plus 8, and then I'm going to go negative 1/3. Now guys, I'm going to tell you, when we're plotting graphs with fractions, go ahead today and get in a habit of putting your fraction in parentheses. So I have negative 1 divided by 3 times x plus 3. Now, when I have a generic problem like this, what I can do is just do what's called zoom standard, which is going to give me my negative 10, positive 10 on the x and the y. So I'm just going to go to zoom and come down to number 6, which is zoom standard. And what's going to happen is it's going to graph the two functions on the same, or the two lines on the same graph. So if I can tap into where these two lines intersect using my calculator, then I can get the solution. Now guys, if you got an error, and I talked about this earlier in a video, but if some reason you didn't watch it, which would be shame on you, if you got an error, you might have to go second function stat plot and turn these things off. So I'm just going to go 4 plots off and hit enter where it says done, and then I'm going to go back to what I had, go back to zoom 6, zoom standard, and I shouldn't get my error. Sometimes if you haven't turned your stat plots off, it'll give you an error, and those kinds of things can be extremely frustrating for an online course like this, because I'm not going to come to your house and fix your calculator for you. But you can always, again, do Google Hangout. All you got to do is say, hey, Dr. Darber, I need to hang out with you, man. These linear functions are driving me insane. I need some more help. You've also got the option of going and seeing our graduate assistants who are in the math lab every day from about 8 to 4. They're really good. One's a local high school teacher. Both of them are working on their masters. Another just graduated from University of Wilmington. Her transcript is all A's. It's amazing. These are smart people. Now they can help you, and they're convenient. But if you work all day long and you need to have a Google Hangout session at 7, 8, 9 o'clock at night, then sometimes I'm available for those. Okay, or just rewatch videos, because everything that I'm going to ask you to do, I will teach you in the videos. I'm not going to require you to do much independent.